a project on the process engineering unit, for use in the manufacture of soft gel capsules for the pharmaceutical industry. Written by Theo Baker. Before starting production, you need to look at why we would use gel capsules over other forms of medication delivery. There are two sides of this, the consumer and production. On the consumer side, gelatin capsules are easy to swallow and dissolve readily in the body, improving the bioavailability of the active substance. Special coatings provide resistance to gastric juices, allowing for release at different points in the digestive tract. In production, there are benefits for using soft gelatin capsules or hard gelatin capsules. In soft gel caps, liquids of all pH can be contained, something unavailable in tablets. Hard gel capsules contain powders, usually of a concentration that can't be pressed into a tablet, or will give a very bad taste. There is a huge complexity in getting from starting point now to producing pharmaceutical-grade gelatin for soft gel caps, with many stages to be considered before the product is released into the market. There are 4 stages of production, starting with pre-production, which consists of testing of materials. A main part of the work and effort is spent on testing the raw gelatin, as raw gelatin is not as tightly controlled as purified water or glycerine. After this stage, we can also predict the final stability and properties of the gel cap. The next stage is the production stage, where the materials are mixed. This is the main part of the production, with most of the inline instrument and process control. Another part of production is storage of the materials at the correct temperature. It is the same vessel used for mixing as well as storage, but with reduced process control and fewer instruments feeding readings into the process control loop. The final part of production is testing of the finished product, mostly destructive testing on the finished gelatin as a final assurance of the quality of the gelatin. Before starting production, each ingredient's parameters needs to be checked and tested. One ingredient requires a lot of additional testing: the raw gelatin. Glycerine makes up 16 to 18% of the mix. Its density is 1.25 grams per milliliter. Pure water makes up 38 to 39% of the mix and is held to the international standards for pure water. Skin or bone-type raw gelatin makes up 43 to 46% of the mix. Usually when receiving gelatin from a vendor for the first time, the gelatin vendors are evaluated through a strict year-long certification process and audited biannually in 152 parameters. The delivered gelatin undergoes stringent preliminary physical, chemical and microbiological tests. For all tests, a solution of 6% gelatin is used. This is known as a 6% aqueous solution. Microbiological cultures are grown in petri dishes. The plates are incubated at 37 degrees Celsius for 48 hours. This will show any bacterial contamination in the sample. Gas chromatography is used for separating and analyzing compounds that can be vaporized without decomposition. This will determine every element in the sample. The viscosity is measured with the 6% aqueous solution at 60 C using the pipette method. Knowing the viscosity of this test sample will tell us the final gelling power. Now we come to test the bloom strength. It is a designation of gel strength and is determined by measuring the weight in grams required to depress a cylindrical indenter of 12.7 ml in diameter to a depth of 4 ml in the standard test bottle. For this, a 6% aqueous solution of gelatin which has been heated to 60 Celsius then chilled for 18 hours at 10 Celsius. You need a water bath type gelatin tank used for melting, mixing and storing the gelatin. The gelatin melting tank has the advantage of compact structure, stable transmission and stable running performance. The mixing/stirring process is operated through connecting loop coupling and is composed of dual split agitators with stable transmission and better homogenization effect. The body includes 3 layers, including the tank liner, heating jacket and heat preservation layer. Heating of the inner tank liner is done with the circulation hot water. This means fast heating, good thermal insulation performance, improvement of the quality of the gelatin and acceleration of the gelatin melting time. During its working process, the machine will suck air and moisture from inside of the tank, leaving a 92.4% vacuum for about 6 hours. pH is checked every 10 minutes. pH is in the range of 3 to 8.5 pH, usually 5 pH at 60 Celsius. For the storage, the gelatin needs to be kept at 60 Celsius as this keeps the gelling power at a maximum while also keeping the gelatin liquid. The mixing tank will also be used as the storage unit. So the only thing left to consider is the transportation from storage to the rollers that press the gelatin into a solid sheet. And for this the best solution is to use some heating tape to keep the gelatin liquid during transportation. In transportation you want a small distance between the holding tank and the rollers. Usually the storage vessel is at a higher elevation and most likely situated on the floor above the rollers. The opacity of gelatin films was determined using a spectrophotometer set at a wavelength of 500 nanometers. The opacities of films were calculated by the following equation: opacity equals absorbance times film thickness. The pergastric acid is 1.5 to 3.5 pH units. It takes 5 to 15 minutes to dissolve. The instrument compresses the capsule for 20 seconds between a plunger attached to a load cell and a platform which is raised. During the test, the platform rises automatically and the load cell indicator displays the value of the resistance of the capsule to the compressive force. After 20 seconds the test is completed and the value displayed represents the hardness of the capsule under test. A hardness of greater than 12 newtons indicates that breakage through embrittlement of the capsule may be expected. For degradation under friction, the sample is mixed with an abrasive substance, silica sand for example, and put in a rotating drum until failure.